Have you ever heard that dreaded phrase, but it works on my machine? Well, today, we're diving into Docker, the platform that basically banished that nightmare for developers everywhere. This is the tool that changed how we build and run software. Let's get right into it. So here's our game plan. We'll start with the big problem Docker was created to solve. Then we'll get into the real nuts and bolts, the Docker file, images, and containers. After that, we'll see how these containers can talk to each other and handle data. Then we'll zoom out to see how this all plugs into a professional workflow. And we'll wrap up with some awesome pro tips to make your life way easier.
Okay, so what was this massive problem that needed a solution as big as Docker? Well, if you've ever written code, you know this pain. You spend weeks building something. It runs perfectly on your laptop, but the second you try to run it somewhere else, on a coworker's computer or server, everything just breaks. It's that classic, it works on my machine headache.
And this is Docker's genius solution. It lets you take your application and literally everything it needs to run, every library, every configuration file, the whole environment, and bundle it all up into one single, neat little package. And what's the result? Your app runs the exact same way every single time, no matter if it's on your machine, a test server, or deep in the cloud. Now, this idea of packaging everything together has a name: containerization. So let's take a closer look at what that really truly means. At its core, Docker is all about containerization. The best way to think about it is like a real-world shipping container, you know? It doesn't matter if you're shipping bananas or car parts, the container is a standard size and shape so it can be moved by any ship or truck. Docker does the exact same thing for software. Now, you might be thinking, wait a minute, isn't that just a virtual machine? And that's a great question, but nope, not quite. A VM has to boot up an entire guest operating system, which makes it big, bulky, and slow. A container, on the other hand, is super lightweight because it just shares the operating system of the host machine. That's why they're so incredibly fast. So how do we tell Docker what to actually pack inside one of these software containers? Well, the whole thing starts with a simple but really powerful text file called the Docker file. Think of the Docker file as a recipe. It's a step-by-step instruction manual for building your application's entire world. It lists every single command needed, from what operating system to start with, to copying your code, to installing all the software it needs to run. All right, so while there are a bunch of commands, these four are the absolute backbone of almost every Docker file you'll ever see. From is your foundation. It tells Docker what base to build on, like a specific version of Linux. Copy is pretty straightforward. It's how you get your own application code into the mix. Run is your workhorse. You use it to execute commands, like installing all the packages your app depends on. And finally, CMD is the grand finale. It's the one command that will run to start your application when the container launches. And here's the really cool part. Each of these commands creates a layer, and Docker is smart enough to cache them. So if you only change your code, it just rebuilds that one little copy layer, making your next build incredibly fast. Okay, so we've got our blueprint all written out. Let's see how Docker actually uses it to bring our application to life. The whole process is this beautiful three-step flow. First, you write the Docker file. That's our blueprint. Second, you use the build command to turn that blueprint into a static, packaged thing called a Docker image. And finally, you run that image, which fires it up as a live active Docker container. So just remember, write, build, run. It's a clean path from a blueprint to a template to a real running app. So that Docker image we just mentioned, that's the actual thing you build. It's a read-only, unchangeable snapshot of your application and its entire environment, all bundled up. And you usually store these images in a central place called a registry. Docker Hub is the most famous one. Think of it like a GitHub, but for Docker images. And this is where the magic really happens. A container is a live, running instance of an image. And the key thing to remember is that containers are lightweight, fast, and completely isolated from each other. They start up in a matter of seconds, and they run in their own private little bubble, so they can't mess with the host computer or any other containers. You know, every container follows a pretty predictable life cycle. It gets created from an image, you can then run it, you can pause it to freeze it in place, or you can stop it. And when you're all done with it, you can just delete it. But what happens when it won't start? If your container fails right after you run it, the very first thing you should do is check its logs. That's your key to debugging. It'll show you the exact error that's causing the problem. Of course, most applications aren't just solo acts. They need to talk to other services. And maybe, most importantly, they need a way to store data that actually sticks around. This is exactly what Docker networking is for. It lets you create these private, virtual networks that your containers can join. So, for example, if you have your web application in one container and your database in another, you just create a network, attach both containers to it, and boom, they can now find and communicate with each other securely just by using their names. It's the fundamental piece that makes complex systems like microservices possible. Now, here's a huge gotcha with containers. By default, when you delete one, all the data created inside it is gone forever. For something like a database, that's a total disaster, right? The solution is Docker volumes. A volume is basically a bridge between a folder inside the container and a folder on your actual computer. This way, all your important data lives safely outside the container, and it'll still be there even if that container is deleted and recreated 100 times. So now that we have all the building blocks, let's zoom out a little and see how all of this comes together in a modern, automated DevOps workflow. In a professional environment, this whole process is usually automated. It starts when a developer pushes new code. That automatically triggers a build of a new Docker image. That image is then pushed up to a registry where, and this is a critical step, it's often scanned for known security vulnerabilities. Then, an orchestration system pulls that trusted image and deploys it to the servers. If traffic suddenly spikes, you can scale up by launching more identical containers. And the whole time, you're constantly using tools to monitor everything to make sure it's all running smoothly. All right, we've covered the whole process. Now let's wrap this up with a few pro tips that make a massive difference in how efficient and secure your containers are. Okay, here are 3 tips that are absolute game changers. First, always try to use the smallest base image you can find, like Alpine Linux. Smaller images build faster, transfer quicker, and have a smaller attack surface. It's a win-win-win. Second, master multi-stage builds. This lets you use a big image with all your build tools to compile your app, but then you copy only the final compiled program into a tiny, clean production image. It's genius. And third, for security, always run your containers with the least privilege possible. By default, containers run as the superuser root, which is risky. A simple change to run as a non-root user dramatically improves your security. So after all that, it really does come back to this one central idea. Docker gives you the incredible power to package up an application with everything it needs, creating a single unit that will run consistently and reliably every single time, no matter where on earth you put it. So now you have the blueprint for containerization. You understand how to package any application so it can run anywhere, free from the works on my machine curse. The only question left is, what will you build first? Thanks for watching.